What's up everybody, JJ here, and it's arrived. The highly anticipated Creality K1 is here. I've been testing it. We've got a lot to talk about. Now first up, I know there is a lot of comparisons between this and the Bamboo P1P, and we're gonna be talking about it a lot. But before I get that printer up here and we do the whole side-by-side connection, first off, I think we should talk just about this one. What is this printer? What does it have? How do I like it? First off, disclaimer to get it out of the way, this was sent to me for free. I was not paid for this review. These are my genuine opinions about it, and I've got the real prints to prove what works, what looks good, what doesn't look good, and what failed for me. So first off, the unboxing. This was the easiest printer to unbox, even easier than the P1P. This one, most of the steps were genuinely how to take the packaging out of it. It's full of foam, and there's definitely a best way to get the foam out of there, so it steps you through there. The hardest part was plugging in the screen. I'm usually pretty slow at unboxings, and this one took even me only about 10 minutes. I bet if you were setting up a bunch of these, you could do these 5 minutes each. There is an auto calibration that runs through and makes sure everything is connected correctly and working, but you didn't have to connect those. Those were connected at the factory. That just makes sure nothing came unplugged or anything. For a beginner or someone who just wants to set up a printer quickly, this was very easy and very hands-off. Like, you can't mess it up, the setup here. Well, you could mess it up if you don't switch the voltage input. There's a slot on the side so you can reach in with a screwdriver and switch the power supply from 110 to 220. So it is important to make sure you are using the correct power input. Next up, let's cover some of the general specs and really things I found interesting about this printer. Also important to note, this is only a $600 printer, so all of these features come in at a really good price point. So the big feature they advertise a lot is speed, and they do get a little carried away with the marketing. I feel like Creality has two different departments, and their engineers and their advertising departments are separate, and it's not one person advertising and making this machine. Because they always like to throw out these huge numbers that are a little unrealistic. If you're expecting to be printing at 600 millimeters per second at 20,000 acceleration all the time, like they mentioned in the ads, that's just not going to happen. You need to slow down around turns. You need to, use slower outer wall speeds than inner wall speeds. It can print at 600 millimeters per second, but that's only in certain situations with certain filaments. You're not going to print most things at those speeds. Here's their little example test that runs it through and does print very quickly. So it is impressive, and it's a very fast printer. I just do think the advertising gets a little carried away. It's Core XY with metal rails. I'm really interested to see the long-term comparison between this and the carbon rails on the P1P. It seems like the steel ones would be more durable than carbon fiber, but I don't really know what stresses and strains are going against those rails anyways. And I also haven't heard of any issues people have had with the P1P rails, so they could both be great. The build volume is 220 by 220 by 250, so similar to an Ender 3 style size. Not as big as the P1P, gives you a little bit more size in the X and Y. But they are coming out with a K1 Max, which will be even bigger. I think it's 300 by 300 by 300. That'll be a really impressive printer. Another cool thing is how small and contained this printer is. It's like a little black box. When you put this cap on the top here, it's very small. 360 millimeters wide, 500 millimeters tall, back of spool to front of display, maybe 520 millimeters. So pretty small and compact with nothing hanging off the sides or top. This really keeps it enclosed. It does have a magnetic top hat on here that holds everything in really well. And with this single piece, you will fully enclose the printer, which is great for high temperature printing. I was able to get some great ABS print off here. I haven't done extensive testing, but this first ABS print I got off here, and I really made it a hard one. This is a hex scraper. I wanted to test something that's large and flat with a lot of sharp corners, and it stuck really well. So very impressive. Bed gets to 100 degrees Celsius. One thing I have heard people worry about is that there's this little crack on the side here. The front door doesn't make a perfect seal because there is a little slot on the front, but that's not where you're going to be losing all your heat. There's a fan on the back that's blowing excess heat out of the printer. That's where you're going to be losing your heat. I'm sure if you wanted to go with even hotter temperatures, you could turn that fan on the back off, but I just kind of left it default and it printed really well. Two tall boy motors in the back for your Core XY system. Small lightweight extruder on here. It's using CAN bus. It runs an automatic input shaper routine, which is great. Same as the P1P. Reduces ringing which is really great. It has a ceramic heater, and I tested it. It could reach 220 degrees Celsius in 40 seconds. The 24-volt bed reaches 60 Celsius in 2 minutes and 12 seconds. I do always prefer a DC bed over an AC bed just because AC voltages are dangerous. And for me, I would rather have it heat up a little bit slower and be a little bit safer. Some people like AC beds. You can like whatever you want. I would take safety over a little bit longer time. It uses a large gear extruder, sort of a LGX style, with a little moon stepper motor on the back. There is a 2-position latch on top for tightening and loosening the gears on the filament. It uses load cells on the bed to do your automatic bed leveling. That also means while it's doing auto bed leveling, you can't be pulling off a print from your last print, because then it messes it up. The bed is guided by 3 lead screws, 3 linear rods, and only 1 motor doing the actual driving of it up and down. I do really like this large internal fan, similar to the Bamboo X1C, and they do sell a fan like this for the P1P, but it doesn't come stock on the P1P. It seems to work really well. It also does this neat trick where it moves over in front of the fan after the print has finished to help cool down the nozzle even faster. I'm not sure if the X1 Carbon does that, but I thought this was cool, so I thought I would mention it. The chassis is really nice. It's this aluminum frame. I think it looks very nice on a shelf. It doesn't look like the standard 2020 aluminum extrusions. So when it comes to the style, I like it. It is gray and black, pretty boring in color, but it's a sleek gray look. The 2 sides are plastic. The front is a tempered glass door, and the top is also plastic. This 4.3-inch touchscreen on the front is really great. I like it so much more than the P1P's touchscreen. They also made this cute little cutout on the door so it fits around the screen as it opens and closes. Seems like this adds a lot of complexity into the manufacturing of this door, all just for getting around this screen instead of moving it down a little bit, but that's what they went with. Internal light bar is pre-installed. On the P1P, you've got to install it yourself. File transfer here is done with a USB flash drive instead of an SD or a micro SD card. I've recently been testing out my first resin 3D printer, and I realized on that one they used a flash drive, which is way better. And I don't know why I never thought about this for 3D printers. SD and micro SD cards are small and flimsy, easy to lose, versus a big flash drive. Putting it in a USB-A port is really easy, and I really like it here. There's also 8 gigs of internal storage, so when you put that flash drive in there, you transfer them from the flash drive onto the internal storage of the printer, and then you can just print it from that internal memory. That way you can remove the flash drive and move on, and this stores it internally. I really like this build plate. I'm not sure exactly what you would call this surface. I think it's similar to what the X1 Carbon has. They say it does require glue, and I think the glue is there to help release off of the print bed. But it is a magnetic bed, so you could really use any print surface you want on here. If you don't like this one, put a different one on there. It holds on really well and releases really well, and the magnetic flexibility of it makes it really easy to pop on and off. So now let's talk about print results and what I was able to get out of this machine. Now we've got on the macro lens and a super bright light to really test out these prints. First off, we got PLA. The white one is their Hyper PLA. Benchy turned out pretty good. Little bit of artifacting. A little bit of cooling issue around here. You can really see it on this one. This is just with some standard silk PLA. And silk PLA will really change its shininess depending on temperature and how fast it's printing. The bottom shiny bit got to melt really well, but the more matte finish is where it didn't get full time to melt. It's more of this little banding artifact coming in. I think that's part of the extruder. Still getting really good first layer on these. Now this is truly a worst case scenario here. The boat turned out pretty good for being so quickly printed. Next up we can move on to our crazy speed test. This was done at 600 millimeters per second. And I don't know why this turned out so good. So first I tried it with the silk PLA, and it did have extrusion issues. It wasn't able to extrude fast enough to do this whole 600 millimeters a second, 20,000 millimeters per second squared acceleration. But this is just some standard silk PLA. I put on their Hyper PLA, and this thing turned out amazing. It's so smooth. This is like the smoothest print I got off this printer, and printed it the fastest. So this shows that the printer is capable of really fast prints and really high quality. So maybe the trick is just to go crazy fast all the time. This was probably the most impressive print of the day. Next up, I wanted to try some matte filament. So can you guess which of these was printed on the P1P and which of these was printed on the K1? Because this shows they both do have some banding artifacts showing up in there. That's just how geared extruders seem to work sometime. But the cat was on the K1 and this plate was done on the P1P. This one does show how beautiful this can be printed at really high speeds. This vase was so quick for how big it is. It's huge. But it does show a bunch of this artifacting still showing up here. And this makes me wonder if I need to be printing with that hyper PLA, or printing slower, or printing faster. This is just using the default profile. I just click Spiralize Outer Contour, and this was what the printer gave me. But the results of this make me think I could do it better. There's something here that I think could be changed to get results that look this good. Next up, I tried a few other filaments to see just how they would work. This octopus is printed in PETG. I think it's some wet PETG because of this extra stringing and some of these little bubbles and holes in the print. I think it was just wet PETG. It's kind of been sitting on a shelf for a few years now, but really testing out that first layer to see it stuck super well, and this is a really difficult print to get prints stuck well. And the default profile worked perfectly. I didn't have to tune this at all. Next up, we've got ABS. This one really blew me away. I wasn't sure how good this printer was going to be, how good of an enclosure it was going to give me, but this is the bottom layer of this print. This thing turned out so good. Those sharp corners there are perfect. No curling at all. And all the way through, super thin, all the way down to the end, and every single corner stuck extremely well. Very impressive. On this side, some of these corners may have a few dots of under extrusion, but that's just a flow calibration to get that tuned a little bit differently. This is with no tuning, just using the default ABS profile. Still having a little bit of these artifacts showing up on this model. Next up was TPU. Pretty bad results here. This is really hard to print TPU, and it's kind of old, so it could be that it's wet, and just using the default profile on a random spool of super flexible TPU. It's maybe a little unrealistic. Let me know what you think about this. Should it be able to print this default? I think with some better TPU or drier TPU or tuning the profile a little bit longer, I bet I could get results out of here. Because it was printing well and it was sticking well, but it does really need some more work or different TPU. The next up, the big fail of the day. This is what their super fast benchy gave me. It was getting so many layer skips. The benchy is supposed to be stacked tall, not sideways like this. This was the default printer with the pre-sliced profile, and I did try it as well with their Hyper PLA and got the same results. It was just skipping layers as it was going up, and I stocked this one a little bit sooner. I know it can print 600 millimeters per second, 20,000 millimeters acceleration when it did this one well, but something about how this one was tuned, it was giving me skipping. This is something I really want to get working. I will post a short about getting this working once I can get a speed benchy off this printer. And now it's time for the thin first layer test. It all held together correctly, but it did get a little thin in a few of the corners. Holding it up to a bright light shows just how much light can still pass through, but I think that bright light makes it look worse than it really is. I'd probably give this a 7 or 8 out of 10 since it did all stick together, and it is extremely thin. It would be able to print another successful layer on top of this if you were printing an object that really did fill out this entire build volume. So it does pass the benchmark, but it's not a perfect pass. So now let's talk about some downsides and cons of this 3D printer. First off, it's loud. This is a loud printer. It's not something you can put in a corner of a room and just ignore it. It's extremely loud. The fans are extremely loud because they're blowing a ton of air, because it's printing so quickly. You could probably tune it down to a slower, quieter profile, and I wish the slicer had that. It just doesn't have it yet. And so currently it's really loud. You really need a separate room to put this in. Even then you might hear it through a wall. Very similar to the P1P, they're both very loud. The next issue is swapping filament on this printer. And it's really just reminds me of most other printers versus the P1P has the greatest filament swapping I've ever used, because it has a blade in there which cuts the filament for you, and then it extrudes that last bit through the nozzle. It just works really well and makes the usability of the printer extremely easy. This one is more like a standard printer. You hit the retract setting and then it heats up the nozzle. Luckily it heats up really quickly and then does a little bit of retracting. Then you got to pull it all the way through the reverse Bowden tube all the way out, and then feed your new filament all the way up in, then do the extrude. It's got to heat back up again, do the extruding, which is disappointing because this feels so much like a P1P until you start swapping filaments, and then this feels like a regular printer again. I would love to see them adding a better filament swapping function in there, if they could somehow work it out to be a little bit better, or if they come out with an AMS system, some sort of filament swapping management system. Oh, I love the AMS on the P1P. I feel like we keep comparing them. Let me just get the P1P up here. It's a big happy printing family. These printers are so similar. The big difference here is that there's nothing mounted up top, and there's the AMS over here. And I rarely even use this for multicolor printing. My favorite feature here is just being able to tell it what filament I want it printed at. Or printing two things at once in a different color. You can tell it to print one object at a time and say I want this Bowden green and this Bowden white. Tell it to print it on opposite sides of the printer, and it'll go over and print one boat in one color, swap out the filaments for you, go over and print another boat in a different color. Multicolor printing just wastes a lot of filament that I don't love, but something like this where you want two objects printed in two different colors at the same time, it makes it really easy, and there's only one filament change in the middle there. And I'm sure they know how great the AMS is, and they're going to be trying to copy it because everyone loves these. They're so great. The next thing to mention is the slicers and the differences between them. Bambu Labs has an amazing slicer when it comes to profiles. There's so many different profiles, so many different materials, and they're all really well tuned. I haven't had many issues. The only issues I've had on this printer are when I'm selecting the wrong profile. If I say the wrong filament, or if I say the wrong bed, if something gets swapped accidentally, then I'll have issues. But if I have the correct thing selected, it just prints really well. This one has two profiles and a few filaments, and the TPU one failed for me. I haven't tried TPU on the P1P, so I would just love to see slower speeds, silent modes, make something like a draft setting, something more high quality settings, just more things in between. Currently there's only two, and I'm sure it's just because it's a new printer and they're still working on those. So again, I'm saying this so Creality knows to work on this. The Bambu slicer isn't perfect though, and I really hate having to upload files from the computer over to the Bambu Labs P1P because it needs internet and their servers to be online. If Google Fiber goes down and we can't access the internet but our local Wi-Fi is still working, I can't upload to here. Or a few times where their cloud servers have gone down. You can't upload from the computer over there in the corner to this printer sitting on this desk. They're a few feet away, but it needs to go to their cloud servers and then all the way back to this. It's just a bunch of extra steps and unnecessary things in the way. It's also not saved locally on the SD card, like you can't go back to your history on here and reprint things you've printed before. On here, it's more like a standard printer where it is uploaded directly to this printer over local Wi-Fi, so it's way quicker and it is saved here. You can go back to your history and reprint things. It also feels like the Creality slicer is trying to be made for print farms. When you're uploading a file, you can select which printers you want to send it to, so you could batch send one sliced file to a bunch of your printers, which is really cool. I don't run a print farm and I've never run a print farm, so I don't know all these things, but that sounds really cool for people who wanted that. So overall, yes, I'm really impressed with the K1 here. I don't know how they did it, how they made this printer when a year ago they put out the Ender 5S1, which I hated, versus this one is a really good printer. It makes the Ender 5S1 look obsolete now. If you're really looking to upgrade, there's a lot of great options now in this $500 to $1,000 price range. It's funny where a year ago, that $500 to $1,000 price range really didn't have many great options. Your options were either to build your own printer or upgrade a cheaper printer or really dive in and spend a lot of money on a plus $1,000 printer. Now you've got this, the Bambu Labs P1P and the Prusa Mark IV, all in that sweet $500 to $1,000 price range. This one I think wins when it comes to price and features. It is the cheapest out of them and has a lot of nice bells and whistles that you might like. The P1P wins for usability. It's so easy to use and swap out filaments. You pop the AMS on there, it just makes usability of it extremely easy. But then the Prusa, I think, still wins in open source, and being able to upgrade older printers to a Mark IV I think is really impressive. And I think it's really impressive that they made a kit that you can upgrade an older printer, so a lot of Mark IIIs aren't going to be thrown into landfills or obsoleted now, because you could upgrade it. You buy a few parts, you upgrade it along the way. I'm really excited that we're getting this sweet competition in this upper end price range. It makes Creality put out really good hardware like this and keep pushing those prices down. The consumers are all winning here. I do hope things don't go too closed source, because that open source model that 3D printers are built on has helped everyone. Everything is built off open source hardware, and I'm not a lawyer and I don't understand patents. So if you are shopping between these three, I can't tell you which one to buy. They all have their unique strengths and weaknesses. Each one has its own little ecosystem you're kind of diving into. But overall, I think it is a really impressive machine. Not as impressive as their advertising may lead you to believe. But if you've pre-ordered one, I think you'll have a good time with it. I'm really glad I have it, and I'm really excited to put a few thousand hours on it, and then we'll know how it really is. This is a very quick overview of this printer. I haven't had it for very long. Also, if you do have any more questions, put them in the comments down below and I can answer you there, or maybe make a short testing out some things that I didn't cover in this video. So you could subscribe so you don't miss any of those. But anyway, go out there and create something amazing today, and I'll see you in the next video.